Right, for this lesson, we are actually going to look at quadratic equations. And this is the reflection of a parabola. Now, you have noticed that we have been looking at the concave arc parabola all these times. What happened when we have reflection of the parabola? By the end of the lesson, you should be able to understand the process of reflecting a parabola on a Cartesian plane. Now you should be able to describe the reflections with respect to the basic parabola, and you should be able to apply reflections to quadratic functions and observe the graphical effects. Again, you need to identify the critical features of a reflected parabola, and finally be able to sketch the reflected parabola given the different forms of the quadratic equation. Now, remember the basic parabola y equals to x squared. You've got axis of symmetry, x equal to 0, the turning point or the vertex at the origin, and this is the minimum because this is a concave arc shape. And you know that both the right and the left arm extend up into infinity. All right. Now, when we look at the turning point form, y equals x minus h all square plus or minus k, or y equals x plus h squared plus or minus k. Alright, you know that k is a vertical translation and h is a horizontal translation. I have been through this a couple of times, so I'm going to let you read this. If you like, pause the video and read it through. Now, use your class pad, please. Sketch y equals to x squared and y equals to minus x squared. What can you observe? Now, if you've done it right, you should get exactly the same as what I've got here on the screen. You can see that the blue line is y equals to x squared and the red line is y equals to minus x squared. Here, y equals to minus x squared is actually the reflection of y equals to x squared, and the reflection line is the x-axis. It's reflected about the x-axis. Alright, so here this shape is a concave down. And for the y equals to minus x squared, you've got a maximum turning point. Alright, again, use your class pad. This time, I would like you to plot y equals x squared plus 2, y equals minus x squared plus 2, y equals minus x squared minus 2. What can you observe? Again, you can see that the blue line here is y equals x squared plus 2. What happened is you have actually moved y equals to x squared up by 2, vertical translation. Now, what you have done when you have included a minus x plus 2, which means you have reflected the basic parabola and then move it up by 2. So therefore, the red line here is y equals to minus x squared plus 2. Then the green line is when you reflect the basic parabola. Maybe I will use a different color, a black color to draw it. So this is the reflected basic parabola. So 1, when it is minus x squared plus 2, you actually move it up by plus 2, and then you move it down by minus 2. This is y equals to minus x squared minus 2. Alright? So you can see that the effect of a minus is actually reflecting the parabola. Then the plus or minus, again, is the plus or minus a constant, again, is the vertical translation. Alright, now let's have a look at the next slide. Again, I would like you to try plotting this and see if you can get the same parabolas as I do. So when you have y equals x minus 3 all square, you know that it's the basic parabola y equals x squared, move across by 3. All right, so y equals to x minus 3 all square. Then with a minus, this is the reflection. Reflected along the x-axis. All right, so the axis of reflection is x-axis. So reflected is y equals to x minus 3 all square. All right, the minus is here. Then when you've got y equals x plus 3, you know it's a basic parabola shifted to the right by, to the left by 3. So this one is y equals x plus 3 all square. And reflected, y equals to minus x plus 3 all square. All right. So a quick summary. Y equals to minus x squared or y equals to minus x squared plus minus k. Okay. It's the vertical translation of y equals to minus x squared. So the axis of symmetry is y equals to y-axis, which is x equals to 0. Turning point is either 0k or 0 minus k. All right? Now, what about the next bit? When we have horizontal translation, again, it's the same. Plus implies moving to the left. Minus implies moving to the right. All right? That's all. So without further ado, well, just going to introduce you straight to the turning point form. All right? So y equals to minus x minus h all square plus k, or y equals to minus x plus h all square plus k. This is the reflection of y equals to x minus h square plus k, and this is the reflection of x plus h all square plus k. That's all. So whatever you do to y equals to x plus h all square plus k, when you have got a minus sign, it's just a reflection. That's all. It just means the negative sign implies that it is a concave down parabola. Now, we have talked about the turning point form. What about the root form? The root form of y equals to minus x plus or minus m multiplied by x plus or minus n. This is actually the reflection of y equals to x plus or minus m times x plus or minus n. That's all. Basically, it's actually the same thing as the root form, but this is the concave down shape. So again, I'm going to leave you to read this slide. Pause it for a while. You know I've been through this, so I'm not going to dwell on it. I would like to go on with identifying the key features of a quadratic function. All right, so here I've got y equals to minus x squared plus bx plus c. In fact, this is when a equals to 1. All right, remember, I am not talking about the dilation factor yet. I'm just talking about a monic. So here, for any negative, it implies concave down, which is what I call the N shape. All right. Same thing, it's got axis of symmetry, the turning point. This time is a maximum turning point. The x-axis intercepts, or the roots, and the y-axis intercept. All right. So same features as the parabola you have known so far, but with some slight changes. All right. It's just reflection. That's all. Again, looking at this, you would have one x-intercept, two x-intercept, or no x-intercept at all. So here I should have said y equals to minus ax squared minus and minus. My apology for not typing it out correctly. All right. So anything with minus means that it's a concave down shape for minus ax squared. All right. A is a dilation factor, which I will discuss tomorrow. Let's do some sketching. First, let's talk about sketching minus x squared minus 8. This one, you know that shape is concave down. Right, you can also see that this is actually a vertical translation of y equals to minus x squared down by 8 units. Alright, so sketching this, I'm going to first identify the axis of symmetry, which is x equals to 0. And then you know that you are moving from the origin O down by 8 units. So let's say this is 8. Alright, so in fact, I don't actually need the arrow. Alright, so here 8 units and that's minus 8. Alright, and I'm going to just sketch it. And this is y equals to minus x squared minus 8. Alright, so that's all you need. What about the next example? Here is y equals to minus x plus 3 all squared minus 4. So you know shape is concave down. Alright, this one. Alright, once you know that it is concave down, the turning point, this is actually a square. Alright, turning point is minus 3 and minus 4. Exactly the same as what we do. And then we look at the axis of symmetry. Is actually x equals to minus 3. And then you know, let's see, work out the y-intercept first. This is when x equals to 0. So y equals to minus 0 plus 3 square minus 4, which is minus 3 square is 9, minus 9, minus 4, which is minus 13. So y-intercept is 0, minus 13. Check for x-intercept when y equals to 0. So 0 equals to minus x plus 3 square minus 4. Alright, so x plus 3 rearranging square equals to minus 4. So there is no solution. So no x-intercept. Alright, let's start sketching. So starting off with axis of symmetry, x equals to minus 3. X equals to minus 3. Now, you know that the y-intercept is 0, minus 13, and then the turning point is minus 3, minus 4. So let's do it, this turning point here, minus 3, minus 4. And if I could sketch this, and this would be the y-intercept 0, minus 13, and this is y equals to minus x plus 3 all square minus 4. Alright? Right. Again, excuse my typing error, this is all square here. Now, let's first look at the shape. The shape, concave down, since there's a negative there. Turning point is 2 and 6. And let's look at y, and then the axis of symmetry is x equals to 2. and then y-intercept when x equals to 0. So y equals to minus 0 minus 2 square plus 6 equals to minus 2 square is 4, so minus 4 plus 6, which is 2. So therefore y-intercept is 0, 2. Let's look at x-intercept. Alright, this is when x equals to 0. Y equals to 0. My fault. So 0 equals to minus x minus 2 square plus 6. So here rearranging x minus 2 square equals to 6. X minus 2 equals to plus or minus square root of 6. X equals to 2 plus or minus square root of 6. So the x-intercepts are 2 plus square root of 6, 0, and 2 minus square root of 6, 0. Now, you should really look at this point here. 2 minus square root of 6. Minus square root of 6 is actually bigger than 2. Therefore, this is on the negative x-axis. So, drawing, let's start sketching with the axis of symmetry. X equals to 2. And then the turning point is 2, 6. You know that y-intercept is 0, 2, and sketching. This point is 2 minus root 6, 0. This point is 2 plus root 6, 0. And the equation is y equals to minus x minus 2 square plus 6. Alright? So let's have a look at the next one. Here, I've asked you to sketch minus x squared minus 6x minus 8. Before we do anything, let's see if we can actually factorize it. So here, factorizing it, first, I'll take out the highest common factor, which is minus. So therefore, I've got x squared plus 6x plus 8. Now, you know that we can actually factorize this term here. Alright, we need two numbers which multiplies to 8 and add up to 6. So, add up to 6 and multiplies to 8. So the two numbers would be 2 and 4. Alright, 2 times 4 is 8, 2 plus 4 is 6. So that's minus x plus 2, x plus 4. So therefore, looking at this, you know that x-intercept, solving for x-intercept, is when y equals to 0. So 0 equals to minus x plus 2, x plus 4. Therefore, x is minus 2 or minus 4. Alright, so the x-intercepts are minus 2, 0 or minus 4, 0. Right? So again, for the y-intercept, read from the equation is actually minus 8, 0, minus 8. Alright, this is the y-intercept. When x equals to 0, y equals 8. Alright, this is the C. And then axis of symmetry is actually x equals to minus 2 plus minus 4 divided by 2. So therefore x equals to minus 3. That's axis of symmetry. So now substituting to find the turning point. Turning point is when x equals to minus 3. So therefore y equals to minus 3 plus 2 minus 3 plus 4. So minus 3 plus 2 is minus 1. Minus 3 plus 4 is 1. So therefore, the turning point is 1, and actually the coordinate is minus 3 and 1. So now we can start sketching the graph. Starting off with x equals to minus 3. So this is the axis of symmetry. X equals to minus 3. Now we know that the turning point is minus 3 and 1. Minus 3, 1. And we know the two roots here, minus 4, 0, minus 2, 0. And if I sketch that, the y-intercept is 0, minus 8. And the equation is y equals to minus x squared minus 6x minus 8. Right, so this is a way of doing it. Right, let's sketch y equals to minus x squared plus 8x plus 13. Just looking at the left-hand side of the equation, you know that you can't really find two numbers that multiplies into 13 and adds up to 8. So therefore, you should actually use completing the square to factorize it. First, knowing that this is minus x squared, the shape would be concave down. Alright, and then the y-intercept is actually 0, 13, reading from the equation. Now let's complete the square. Y equals to minus, I'm going to take that out, take the minus out, x squared minus 8x minus 13. Alright, so therefore I now have minus x squared minus 8x plus 8 over 2 square minus 8 over 2 square minus 13, which is minus x squared minus 8x plus 8 over 2 is 4, 4 squared is 16, minus 16 minus 13. Therefore is minus x minus 4 square minus 29. Alright, now then we bring the minus sign in. Multiply in, I've got minus x minus 4 square plus 29. Alright, straight away you can see that the turning point is actually 429. This is the turning point form. Alright. And then the axis of symmetry is actually x equals to 4. Right, now we need to find the x-intercept. So for the x-intercept, is when y equals to 0. Therefore, 0 equals to minus x minus 4 square plus 29. Alright, rearranging x minus 4 square equals to 29, x minus 4 equals to plus or minus square root of 29, and x therefore equals to 4 plus or minus square root of 29. So therefore, you know that the 2 points is 4 plus square root of 29, 0, and 4 minus square root of 29, 0. Again, you know that minus square root of 29 is actually bigger than 4. Therefore, you can see that this line, this point here, is the negative x-axis. Alright, let's start sketching. Starting off, axis of symmetry, x equals to 4. X equals to 4. And then you know that the turning point is a maximum because it's actually concave up. So here is 429, and I'm just going to sketch the parabola before I mark all the other points. Alright, so here would be 0, 13. This point here is actually 4 minus square root of 29, 0. And this point here is 4 plus square root of 29, 0. And the equation of the line is y equals to minus x squared plus 8x plus 13. Right, so you can see that the reflection of a parabola is actually just a concave down shape, and anything with a minus sign in front will give you the concave down shape. So this is the end of the lesson.